All right, so you should have out worksheet 10 and 12, but I have a warm-up that's really important because this is very much a question that is on both next week's quiz and the final. It's a systems question that isn't real complicated except for one little piece of information. All right, so Miss Abruzzo wrote this lovely question. It says, one of Santa's best elves, Buddy, was busy making toy cars and dolls last night. Elves are actually paid to make toys, bet you didn't know that. He is paid $1.50 for each car he makes and $4.50 for each doll he made, and last night he made a total of $75. He produced 3 times as many dolls as cars. That's what messes everybody up. All right. So define your variables. So what do we want X and Y to represent? You have to do this on the quiz and the final. Okay. Is it paid amount paid for each car? Don't we already know that? Okay. So number of cars he makes and number of dolls he makes. So be real careful. All right. Now, one equation is pretty straightforward. Got that one, Tristan, for us? Okay. Everybody good? That one's easy peasy. All right. The other equation is the one that messes everybody up so bad. He made 3 times as many dolls as cars. That's the question. Is it 3x or 3y? Okay, wait a minute. Give me some numbers that would work. Dolls, cars. 3 times as many dolls. So if this was 6, this would be 2, right? If this was 12, this would be 4. So which one are you multiplying by 3 to get the other one? 3 times the dolls is equal to the cars? Okay, 3 times the cars is equal to the dolls. Let me read it and think about this. He produced 3 times as many dolls as cars. So which is the bigger number? Dolls. So you can't multiply the bigger number by 3 again to get the smaller number, right? You have to take the number of cars times 3 to get the number of dolls. But that's what everybody does. They do it backwards, okay? And then at the end of the problem, they don't check, and it doesn't make any sense. Okay. Well, how could we solve this system? We could do a matrix, but I wouldn't. I would just do substitution, absolutely, because it's all set up for that, right? If we just plug this in here. So help me out real quick, guys. 1.5x plus 4.5 times 3x equals 75. 4.5 times 3 is 13.5 plus this 1.5 out here. That's a plus in the middle, sorry. 13.5 is at 15 plus 1.5. Okay, we divide and get 5. Yes, 75 divided by 15 is 5. Okay, so he made 5 what? And, okay, if we plug that back in, put a 5 in there, $15. Now, reread the question, and does it make sense? 3 times as many dolls as cars. Okay, so can you see why I'm a little nervous about that question? Be pretty easy to, okay. Now, you could go back and do 5 times 150 plus 450 times 15 and make sure it totaled 75, but all right. This is also kind of a warm-up, but you actually have this one. This is at the top of worksheet 10, I think. Okay, quick review. Do you remember how to multiply matrices? Anybody remember anything about it? How do you know you can multiply matrices? Yeah, like if I had a 2 by 5, tell me one I could multiply it by. Okay? Because these have to be the same, and the answer or the resulting matrix would be a 2 by 4. Everybody remembers that business? Okay. This example is just a 2 by 2 times a 2 by 2, so it's okay. We can do it, and we'll get a 2 by 2. But does anybody remember how it goes? It's row times column. So 2 times -1 plus 4 times 0 would be? Yeah, so just -2. All right, then if I do that same row times the second column, I get the first row, second column over here. So 2 times 5 plus 4 times -2. 10 minus 8, is that right? Okay. Second row, first column gives me second row, first column. So -3 times -1 plus -1 times 0, which is just 3. And then finally, second row, second column. So -3 times 5 plus -1 times -2. That's -15 plus 2, I think. How did I do? Okay. It says now to switch the order around and do B times A. This doesn't sound very fun to me. But do you understand that you would get a different answer because you're using the rows on this one now and the columns on this one, okay? We could do it in our calculator. Do you remember how to do it in your calculator? Enter this. Yeah. Enter this in A and this in B, and then on the home screen just say B times A. Be careful what it asks for. All right. I really don't want to spend too much time on that. I just wanted to review one once. Could we do A times B here? This is a 2 by 2, and this is a 2 by 3. Could we do A times B? Yes, we would get a 2 by 3. Okay, but then they ask us to do B times A. So then you would be saying I have a 2 by 3 times a 2 by 2. Is that going to work? No. We good? Okay, so I don't want to do that one. I just want to talk about it. All right. When you multiply matrices together, sometimes you will get what is called an identity matrix, which is it will look just like if we multiplied this matrix times this matrix and we got this, it's called an identity matrix. It means it cancels everything out when you multiply those together. The identity matrix is going to be important for solving because if I said this multiplied by xy gave me 7, 8, what would that mean? I want you to practice what we just talked about with the multiplication. This row times this column would mean what? 1x plus 0y equals what according to this answer? 7. This row times this column would be 0x plus 1y equals over here 8. Did we just solve this? This would mean x equals 7 and y equals 8, right? Okay, so if we can get an identity matrix and it's equal, it'll help us solve it by what's called an inverse. Okay, I'm going to back up and we're going to do this example because this is really practice of why you would multiply matrices. And there's a question on the quiz and the test about something similar. Holly, Joelle, and Louisa are competitive skaters. Their routines are judged on skating skill, choreography, and interpretation. In a recent competition, they received the following scores: 6, 4, 1, 3, 5, 1, 2, 4, 6. Okay? One of 2 weighted systems shown below will be used. Okay? So they're trying to decide, The judges, it's like they're doing, maybe right now they're using system A, but they're investigating whether they should switch to system B. System A weights it 20%, 50%, 30%, but system B would weight the skating skill 40%, okay, and the choreography and interpretation each 30%. Right now, choreography gets a big 50%, right? So we got to decide which system we like better. And maybe we want to vote, if I'm Holly, which one do I like? If I'm Joelle, which one do I like? If I'm Louisa, which one do I like? Okay. The reason we're talking about this is because if we multiply these together, what size is this one? Okay. And the 3 rows in this one represent what? Yes, their names, right? And the 3 here represents, can I call them the categories? All right, this matrix is a 3 by 2, where this 3 represents, yeah, the categories again, right? And this 2 represents, yeah, whether we're going to use A or B. So if I multiply them together, which I can because these are equal, okay, what will I end up with? A 3 by 2 answer that will be their names by their scores on each system. So I'm going to have Holly, Joelle, and Louisa, and their score for under system A and their score under system B. All right, type fast. Yes, for the percentages, you need to put in decimals. Great question. I should have mentioned that. Okay. So matrix A was a 3 by 3, yes. And 642. Someone read me the second row. 351. 2, 4, 6. Excellent. Okay. Then I go back in, and I got to be careful to go to matrix B. And this one was a 3 by 2. All right. Can anybody read me the percents? All right. So now, thank you very much. Now, if I go to the home screen, I want matrix A first, and then times matrix B. Anyone else get that? Okay, so we have a matrix showing that 3.8, 3.4, 4.2. Under system A, those would be their scores, right? So who would like system A? Holly, okay. Oh, they're trying to get the high score. Yeah, thanks. Somebody fix me. I don't know which number is bigger. Okay, so Louisa would definitely favor A, right? All right, B was 4.2, 3, and 3.8. So who favors? Yeah, Holly would win under B. Okay. Joelle didn't win under either one, but she had a better, she was closer under A. Okay. The question on the quiz says, here's an inventory of items, okay, and here's their value. If you multiply them together, okay, you'll get the value of your inventory. So we'll practice that, but that's the kind of question that's on the quiz. All right. I'm skipping all this because we're going to just talk about how you use an inverse. All right, so example 4 says determine whether A and B are inverses. And they are, because when you multiply A times B or B times A, you get this inverse or this identity matrix, okay? So why don't you just take a second to write down A times B would give you 1, 0, 0, 1, and B times A would also give you 1, 0, 0, 1, and this is called the identity matrix. Just so you have seen that vocabulary and written it down somewhere. We're not going over all that other crazy business. This was number 4. I don't want to take time to type them in even. It's pretty okay. Identity matrix, guys, always has zeros except for the diagonal from left to right. And an identity matrix is always square. What does that mean, a square matrix? Yeah, like 3 by 3, 4 by 4, 2 by 2. Everybody good? That would be a square matrix. Okay. So on number 5, I typed it in A times B, B times A. Are these identities? These are not inverses of each other because when you type A times B and B times A, you don't get the identity matrix, okay? So just write not inverses because A times B does not equal the identity matrix. And the same is true the other way if you want to write it, but all right, so we saved some time by not typing those in. All right, now I'm going to show you why you use an inverse. On your calculator, that key that we keep touching for the matrix key is actually called an inverse, and you're going to use the inverse key to find the inverse of a matrix, and you're going to use an inverse to solve. I don't think I even want to do this question. I'm going to jump to why we use an inverse. Okay. So what happens? Look at this, guys. If I had this situation, they rewrote it. They put 2, -3, -3, 5 times xy. You have to be able to do this on a quiz, and it's super easy. All they did is rewrote it as a matrix multiplication because, help me out here, if I multiplied this times this, what would I get? 2x minus 3y equals -1. If I multiplied the second row times this, I'd get -3x plus 5y equals 3. Does everybody understand? All we're doing is taking this and getting rid of the x and y, putting them in their own little separate matrix, and set an equal to a separate answer. Okay, if this is multiply, doesn't it seem like if we could divide that answer over there, we would get xy? Okay, there's no such thing as dividing matrices. Guess what we're going to use? The inverse. Okay, so we're going to do inverse of A times B. Inverse of A times B will give us this little XY matrix, which is going to tell us the answer. So let's do one we can do. Here we go. Yes. I don't know where it is. On the back, I'm guessing, maybe?
Oh, yeah.
Okay. Mine just says example. So this is on 10B. So first thing we need to do is rewrite this as a matrix multiplication, and that's what you have to do on the quiz. To rewrite it like this. Everybody seem okay with that step? We'll practice it in a minute, but okay. Then what we're going to do is we're going to put this in matrix A, and type the inverse of this times this, and it's going to tell us the solution. So we're going to put this one in A and this one in B. Can you do that? So what size is A going to be? Please be doing this, guys. Keaton. This is the easiest unit we have done all year because it's all on the calculator. But you're going to have no idea what you're doing if you're not taking the notes and practicing this with us. All right, so I am going to edit A, and it is going to be a 2 by 2. And I have 3, -7, -1, 2. Everybody got that one in? Okay, then I'm going to quit. And I'm going to put in B. What size is B, though? B is this tiny little 2 by 1. And it's -16 and 8. All right, then you go to the home screen. Okay. Now, what if we wanted to take B and divide it by A to find out what X and Y are? Can't do that. But the order you're going to put it in is A, so put the name of A, and then do that -1 key without hitting second. So it's going to say A to the -1. And then you could just put B. I'm going to go ahead and put times B, the name of B, so that I have this on my home screen. Okay, as soon as I do that, it's going to tell us what X and Y are. -24. What was it, guys? -24 and... Okay, and that was this matrix we solved for, so it's X and Y, so the answer is just -24, -8. Let me put a couple things on this slide. Maybe just this. Yeah. Okay. They want us to do this one. So, you know what? To save time, I'm going to skip this one. Let's go to these that aren't set up for us. How would you set up number 7? -2, 5. No, because we're not doing an augmented matrix, guys. I was very nice to you on the quiz, though, I wrote this. Does that help? Okay, so you're not going to get confused and do the augmented matrix here because I wrote that. What are you going to do instead? -2, 5 equals 24. 3, -1 equals -10. And what did we do in here? This row times this column was X and Y. Do you need me to go over that again, how that works? If you multiply this row times this column, you'd get 24. So you'd have -2X. People do the craziest things on this, and that's all you have to do. Everybody okay? So help me set up 8, and then we'll go to the calculator. What is 8 going to look like? I would give you this. One. Okay. Everybody good? Because this was X plus 0, Y minus 1, Z equals -4. And that was -4, okay? And what goes in this one? Okay. All right. So let's do number 8. If somebody's speedy and wants to go back and do number 7 for us, you put this in A, you put this in B, and then you do inverse of A times B on your home screen. And it's going to give you the XY matrix. I'm going to demonstrate 8, but you guys can probably get both of them done in the amount of time it takes me to do 8. So if I'm doing 8, I need a 3 by 3. Okay, I'm going to pretend I'm confident that I have that in right. And if I'm doing this one, what size is B, guys? 3 by 1. 5. Negative 4 and 0. Did I get it right? Okay. Now, I'm going to do this again just to show you, but honestly, does anybody know what we could do right now? Yeah, you could go up to this one and just hit enter. Actually, because it's the last thing you did, you could just hit enter and it will do it again. But because we changed the values. But real quick, it was, whoops, let's do that. Matrix button, name of A, then the matrix button to get the negative 1, and then times matrix button, name of B. All right, so negative 1, 0, 3 is what this one gave us. And what is that telling us? It's telling us X, Y, Z. So the question on the quiz says this. It gives you this setup and then says find this. So you're going to write what? Negative 1, 0, 3. Did anybody take time to do number 7? What did you get? So the ordered pair, negative 2 and 4. Whoops. It's nice that the worksheet does show you it works on 2 or 3 because sometimes students think it only works on systems of 3. All right. You know what? Let's have a race. You guys do 9 the way I just taught you, and I'm going to do it by hand. I think I can beat you, unless someone already... I'm going to use elimination. What'd you get? All right, so sometimes it's just as fast to do it by hand, right? I would not recommend a 3 by 3 by hand, but in reality, I'm not, if I set it up like this on your paper, and then I ask you for the answer. Do you remember what we did yesterday? We put it all in one matrix and did RREF. Am I going to know how you put it in the matrix? No. So if you choose to put it all in one and do RREF, I'm not going to know the difference. Okay? Sure. Somebody want to do RREF and someone else want to do this way we're supposed to be doing now, A inverse of A times B. What am I supposed to be doing? By hand, or can I use my calculator? I don't think I can beat you by hand on a 3x3. Does it not work after all that? Okay, you're getting an error. I'm doing it by RREF, and I think I'm going to get no solution probably. What do you guys? Yes. Okay, yours isn't working, right? What is it saying? Error. Okay. That means it doesn't have an inverse. I did it by RREF, meaning I put it all in one matrix, and I got 1, 0, negative 0.40, and then I got 0, 1, negative 1.80, and then I got 0, 0, 0, 1. What does that mean? Do you remember from yesterday? 0, 0, 0, 1 means no solution. Okay, so I tricked you. Can't do that one. All right. These are your 5 problems tonight. Okay? But we are also going to do 12 side B right now. What? Your assignment is also to do worksheet 12 side A for homework. All right. So here we go on side B. You ready? This is the idea for tomorrow. It says Jack and Jill own a small bakery that makes fresh cookies daily. They bake 2 kinds of cookies, plain cookies and cookies with icing. The cookies are sold by the box, and Jack and Jill are confident they can sell all the cookies they make, but there are 3 constraints, and that's a vocabulary word you're going to need to know eventually. It will ask you on the quiz to find the constraints that limit their production today. 1 box of plain cookies requires 1.2 pounds of cookie dough, and iced cookies 0.9 cookie dough. They have 72 pounds of icing, of cookie dough, I'm sorry. For icing, the plain cookies don't take any, but the iced cookies take 0.4 pounds of icing, and they have 20 pounds of icing to work with. As for time, the plain cookies take 1/10 of an hour, the iced cookies take 0.15 of an hour, and they have 9 hours for preparation. Write 3 constraint inequalities, then find the intersection of these inequalities to show all the combinations of cookies they could make. All right, so they helped us out. They said X is the number of plain cookies and Y is the number of iced cookies. All right, so I'm going to write these down, and then I'm going to copy and paste them to the slide so we can graph them. We need an equation about dough, guys. X boxes of plain cookies, and each one of those X requires 1.2 pounds of dough. So 1.2 times the plain ones, plus how much for the iced ones? 0.9 times the iced ones has to stay less than or equal to how much dough do we have to work with? 72 pounds. Everybody okay? All right, then we have an equation about icing. Plain cookies don't take any icing, so we have 0x, but we have how much icing for the iced cookies? 0.4y, and we have to stay less than or equal to 20 pounds of icing. And then we have an equation about time. It takes what? Somebody tell me that equation. Less than or equal to 9. Yep. All right. So I am going to copy all 3 of these equations. Yo! What did I just do? Whew, heart attack. Copy all that to this page. And what we're going to do is graph these. All right. Now, does this look real fun to solve in y equals form? Okay. The way I would suggest is to do your zeros. We're going to graph them by their zeros. So for the red equation, if I put in x equals 0 in, this will be gone and it will just say 0.9y equals 72. So can you solve that? What's 72 divided by 0.9? 80? Okay. Now how will I find the other 0? This time I want to put the 0 in for the y, right? 0 in for the y, and this will be gone, so it'll say 1.2x equals 72. 72 divided by 1.2 is 60. So what we found is the intercepts, 0, 80, and 60, 0. You could have solved that equation and gotten that same idea, but this seems faster to me because we got all those ugly decimals. Everybody okay? Now, it says less than or equal to 72. By the way, I totally forgot to mention, there are 2 hidden constraints. We call these hidden constraints. In other words, they weren't clearly stated, but x can't be negative and y can't be negative. Does that make sense? X is greater than or equal to 0, y is greater than or equal to 0. So we had to be in the first quadrant because we can't have negative packages of cookies. All right, again, this was a less than, so we're talking below this line. All right, second constraint. The frosting, well, this one we could get the y by itself by just doing what? Yeah, 20 divided by 0.4, which is 50. Okay, y equals 50 is what kind of a line, guys? Horizontal or vertical? Got to get that right. Yeah, y equals 50 is this line. We have to stay under here. Everybody good? Can't make more than that. All right, and the green line, how are we going to graph that one? You want to do the zeros again? If x equals 0, we'd have 90 divided by 0.15. Help me, 90 divided by 0.15. 9. 9 divided by 0.15. Thank you. 60. Okay. And then if we put the 0 in for the y, we would just have 9 divided by 0.1, which would be 90. All right. Over 0 and up 60. Over 90 and up 0 gives us this line. Okay. We have to stay above or below that line? Below? Everybody okay? Now, I'm going to pick purple here. Where in the world are all the points that work? They are bounded by this. They have to stay below the red, so here. Stay below the green, so here. And below the blue, so here. This is the region that works. You have to do this on the quiz. I give you the equations and ask you to find the corner points. Okay, what are the corner points, guys? 0, 0, yay, that was easy. What's this corner point? 0, 50. What's this corner point? 60, 0. Okay, now it's a little trickier. what was true on the blue line at all times? This was y equals 50, right? So this corner point right here is on the blue line, so the y has to be 50. And what other line did it intersect? The blue line hit the what right there? Green line? Okay. So if we plugged 50 back into the green line, someone do 0.15 times 50. 7.5. That'll do 9 minus 7.5. And then divide by 0.1. Get 15, right? So this is actually 1550 is where that corner point is. All right, where's the last corner point? What two lines are intersecting right there? What color? The green line and the red line, yes? Okay, I need to know where the green and red intersect. I have 1.2x plus 0.9y equals 72, and 0.1x plus 0.15y equals 9. How about an RREF moment? Anybody got time to type that in? It's a 2 by 3. Matrix, edit, 2 by 3. 1.2, 0.9, 72. 0.1, 0.15, and 9. And then I'm going to go RREF, which is under math. And the name I put it in was A. Okay. So I got a matrix that said 1, 0, 30, 0, 1, 30, 40. So it's 30, 40. Is it looking like 30, 40 on your paper? Were they intersected at all? Huh? Or did I put something in wrong? Does it look like over 30 and up 40 on your paper where they intersected? Is mine just a mess? Mine looks more like 40, 30. Yours looks like 30, 40? Okay, so mine is just not drawn well. All right, the maximization process comes from if every box of cookies that was plain makes $2 and iced makes $3, the maximum profit occurs at one of these points. So if I put 0.50 in to this equation, 0 and 50 would give me $150. Somebody give me another point. 0, 0 would give me $0. What did we have? 80, 0 would give me $160. What was the last one? 1550 would give me 150 plus 30 would be $180. And then there was one more, 3040. If I put that in here, I'd have 60 plus 120 is $180. So either this or this one would give them the best profit. Okay? The maximum profit occurs at one of the corner points. More on this tomorrow. Okay, so one more time, the homework assignment was this.